Okay, let's kick off. So, good morning, everybody. Morning. Hey, come on, wake up. All right. So I'm going to talk to you about MongoDB. Hands up, who's heard of MongoDB? Okay, well, I can go home. All right, I need to do this. Okay, so a little bit about me to kick off. So my name is Chris Harris. I work for Tengen, the company behind MongoDB. So we build MongoDB and then we offer support on the services. I spend my time basically helping out some of our larger clients with their MongoDB implementations. So I'm pretty busy helping some pretty big clients. Before Tengen, I was actually at SpringSource. So I can tell you all about the Spring framework if you really want. I'm based in London, so you see a lot of my roles are EMEA roles. Before that, I was at JBoss. So I've built a fair amount of large-scale enterprise applications. And to be honest, the reason that I left here to join here was almost one very simple reason. It was the fact that over the years here, we figured out how to scale horizontally app servers, right? I can now go from one app server, one Tomcat, to 12, right? Yeah, that's fairly easy. But the issue is, well, they all talk to a single database, right? So you just end up with a single point of failure. So if you basically follow traditional architecture for the blueprint, you go through all the steps, you end up in the ditch again, right? I've been in this ditch so many times that I'm getting a bit sick of it. So when I'm in the ditch, I get rather frustrated. I smash my machine up a little bit. And I go to my boss and he says, "Why have you smashed your machine up again?" And I'm like, well, I have this relational database that just doesn't scale. And I go, I know how to fix this. Duct tape. Duct tape everywhere, right? That's not my daughter, by the way. All right. So if you basically start off with the idea that I've got the ability to scale my application horizontally, there must be a better way to think about how do I manage my data, right? Is there a way of scaling my data horizontally? So, is there a better way? Why are we here? Why do I care? Right. So let's talk briefly about MongoDB. So MongoDB is a NoSQL store that stores JSON documents. So for those of you who aren't familiar with MongoDB, this is a useful little starting point because I'm going to be using these terms and you can refer back to this traditional relational database terms. So obviously we store JSON documents. So JSON documents are the equivalent of rows in my database, right? Let's say I've got a JSON document that represents a product or a user or whatever it is, right? So I have many of these and they live in collections, right? So I have a collection like a table. And obviously I want to be able to access my data extremely quickly, so I do indexing, very much like a relational database does indexing, right? But I can index any of my properties in my JSON document. We're representing the data in a slightly different way, so we don't do joins, we do embedding and linking, which I'll talk about. Obviously, I'm talking about scaling my database. Oh, I almost had a relation on that. my database horizontally. I'm talking not going from one server, one database server to 10 to I've got clients with hundreds of database servers. Right? So this is not, you can start small and then scale as you want to do that. And we scale with a technique called sharding, which I'll talk about. So this is basically the way I look at my life, right? There's different NoSQL stores around there. There's key value stores, which are extremely powerful, right? They're extremely fast. I have the key and I have a value. Well, that's It basically says what it does on the tin. But if I don't have the key, life gets a bit more difficult because let's say I want to find me all products that are greater than $50. Complex queries get a bit more difficult because I don't have the key. Now, you could say, well, if I want to have a lot of functionality, I could use a relational database. So we're living almost at the edge of a cliff, right? So my life is I'm staring down the edge of the cliff saying, I want to give you as much functionality as I possibly can give you, but not fall off the cliff because I want to still be able to scale horizontally. Now, if I add too much functionality, I end up down here, and I can't scale horizontally anymore, right? So there's different ways of representing the data to give you the ability to do grouping, complex queries, to be able to also partition your data across hundreds of machines. So, obviously, there's lots of different ways in which you could use MongoDB. I'm going to talk about Spring Data today. Obviously, we're at Spring Conference, so let's talk about Spring Data. So let's start at the basics and build a very basic app. So here's my first little requirement. Right? I'm going to start off very simply. I want to build a news application. I have articles, right? Actually, a lot of people I work for are broadcasting companies, so I'm using this example. So imagine I've got a news article, right? So as a user, I should be able to create a news article, right? So make it really, really simple, right? Now, I'm Jason. So what does a news article look like in my world? Well, obviously, here's my little curly brackets. And I have properties, right? So title, what's new in MongoDB, the date, the author, the text, and a bunch of other stuff, right? This is how MongoDB is going to store that data, right? It's going to store it as a JSON document. So if we know that, see if we can get this guy to work. Basically, I'm a bit crazy because I didn't prepare very much. I'm just going to build most of my app. So here's MongoDB. It's not running right now. It's not installed. There's no prepared data, right? So I'm going to start it up, tell it where I'm going to store my data, right? All it needs is a DB path. So obviously, it's a database. It needs to store the data somewhere. Done. MongoDB is running. Okay, so MongoDB is running. Let's look at my little example here. This is Spring. I have an article. It's just a very simple class, has a bunch of properties. It's annotated with @document, right? This is going to be represented in MongoDB as a JSON document. It has an ID, sure, right? Has an ID like a primary key. Complicated, right? And then it has a bunch of other properties like author, date, title, text, right? Okay. I've got a very simple Spring configuration, so I'm not actually doing any trickery here. Yes, it's XML, sorry. So here's a little bit of XML. Basically here is Mongo, which is going to be my connection pool, and a bunch of options I can give this pool, right? So you typically would only have one instance of Mongo, because that's your connection pool. And then Spring Data has this concept of a template, and here's the template class, and it takes the connection pool, and this other constructor value is the name of my database that I'm going to store my data. Right? So I'm going to store it in news because I'm going to create a news kind of application. Just look at my very simple app to start with. App. Here it is. So I'm just going to load the Spring context, get hold of my template, and I create an instance of article. Right? So I set some properties, the author ID, the author name, the date, the title, whatever. Yeah. Then I can just say insert. And with a little bit of luck, just prints out some logging information. I go to my Mongo shell, so this is actually the shell straight onto the database. I say show DBs. Okay, it's got a news database. Ooh. There was no create database, right? No create collections. To make it very, very simple, right? Show collections. A little bit of luck, I've got nothing. That's because I didn't say use news. Show collections. There you go. So now I can say db.article. So article is my collection. So these are going to be all my articles are. Dot find. Okay. Now there's some data in there, and I assume you can't read that. So let's make it pretty. Okay. So there's a little shortcut in the shell to just print out and reformat the data. So this is basically my class. Here it is, the author, the Chris, the title. And this is exactly what I stored in here. Okay? Not in there, sorry, beg your pardon. In here. Right, so these are just the properties, right? So you can see a very close relationship now between my article and what I have in MongoDB. Right? This is my class. Obviously, saving data is interesting enough, right? I just inserted. We've been doing that for a long while. So let's go back here. So now someone says to me, well, yes, you've created an article. Now I want to find my articles, right, by a name. Okay? Sounds like a very simple requirement. I should be able to do that. So let's extend this a little bit further and say example number 2, which is exactly the same thing. Let's close all these. And go here. Here I'm going to do, just get the template as I did before. I'm going to say article.findOne. Here's a query where the author is Chris. Right? So basically, find me a document, find me one document where the author is Chris, and return me a type of article. Right? So what's going to happen here is this is Spring Data MongoDB going to map that document that's in my MongoDB, the JSON document, and remap it back to my article class and return it back to me. Right? And I could put, obviously, more complex queries in there, like find me where less than, greater than, not equal to, more complex queries, right? But let's do a very basic one to start with. And with a bit of luck, that should print out some reference, right? So it's got my article back. So it's got instance of my class back, article, right? Because it's found one of them. Fairly straightforward, yeah? Now, Spring Data itself, you can use Mongo operations to do things like I'm doing here, like find one, or find, which gives you back a list. You could do updates and inserts and more interesting things. But what you can also do is use something called the repositories. So the repositories builds on top of the MongoDB operations and gives you another level of abstraction. So now, if I look at here, I can basically say find by author. This time I'm going to say get me back the article repository. Right? So rather than getting back the template, I can get back something called a repository. Right? So here's my article repository.class. Find by author. Chris returns me back the article. What is this class article repository? Well, if we have a look at it, actually, all this is an interface. So it extends CRUD repository, which is a Spring Data interface that you're extending, and you're telling it it's of type article, and the primary key is object ID. It could be a string, it could be any serialized type you like. So here I can actually put my own finder methods in here, so find by author and string author, and Spring Data will generate me that finder method for me. I don't actually have to create an implementation of this repository. Spring Data does it. And all you simply do is you tell Spring Data that, where's my config gone? That I have a package of repositories, right? So you might have one for, yeah. Correct, yes. It's all about convention. You can actually, if you wanted to, you can put an extra annotation at top of your finder methods and give it the query to execute.
You could run into issues with that when you do
sure.
turn off compilation.
Yeah, it's useful for convenience, but obviously if you want to do, typically for my preference, if I want to do more advanced queries, I typically will go back and just use Mongo operations, which just gives me more power. But all you're doing is giving it a class of package of repositories, and then it will generate you the implementations of them repositories. So you can say find by user, you could say find by user, find by author and timestamp or and title, and you could say not. There's a bunch of conventions that you can use to define your methods. So it's fairly simple to do. So if I go here, obviously this is it's the same syntax that I had before, same application I had before, but this time I'm going through the repositories. So it gives me Chris. Yeah, so by author. So what it's going to do is look in here and use author. It's convention, yeah. It's technically the parameter names, yeah. Okay. So if I run this now, obviously I expect to get my article back. And I've only got one, so I'm only getting one. That's fine. Okay. If you want to find out more about the repositories, and know Oliver's doing a talk later on to go deep into how the repositories actually work. But if you think about this, I'm a document store, right? So I don't have rows and columns anymore. I actually have JSON documents. Oh, this is interesting. What can I do with this? Well, one of the big appeals for MongoDB for many people is I may be working on an application that's, has many releases, or I'm working in an agile project that has many sprints. So imagine I get to this story and I show my product manager and he goes, like, I've done the first two stories and I've shown my product manager and he goes, that's all nice. You can create articles and you can find them by author. That's really nice. We can put a UI in front of it. But actually, if you look at all the other news websites that are out there, they're now doing social content. People can comment on stuff. They can rate stuff. They can have all these social aspects. Let's add commenting. Oh, okay. Right. So now I've got to add commenting. Now, MongoDB in itself is schema-free, right? So it has no restrictions in terms of validation at the database level. It's in your app, mostly. So I can now add comments to my existing documents, right? I don't have to go on and do large alter tables and change my database schema. I can do this as I build my application. I can't remember. So what I'm going to do here is take my existing JSON document. Here it is. It's got some basic properties we had before, and I can add comments, right? So I could say comments is now an array. Notice this is an array of other documents. So documents can have documents embedded in them, and arrays of documents embedded in them. So now I can say this is the author of the comment, blah, blah, right? Different properties that he's got. How do I do this? How do I do this without having to do large alter tables and restructuring my database? So if I go to example number 4, which is up here. Here I've got article as I had before. Article now has a list of comments. Fine. I have a comment which has an author, text, and a date, right? Fairly simple. Now my application is going to do something quite interesting here. So what I'm going to do, get rid of that. What I'm going to do here is I'm going to get hold of my Mongo operations, you know, the underlying ability to talk to the database. So I'm going to create an instance of comment. No, I'm not going to find the article first and then add something into the array and do something like that. Basically, I can create a comment, right? So this is Bob, right? He wants to put a date and text, fine, whatever. DB operations dot upsert query. This is the query part of my operation I'm going to perform. This is all going to perform in one transaction, right? So MongoDB supports transactions at a document level. So now this is going to be atomic. So I can say, query where the author is Chris, so find me the documents where the author is Chris. In the same operation, update this document that you found and push comments. And here's the comment that when I want to push. So I'm going to push this comment, this thing up here, into a field called comments. I don't have a field called comments, but it doesn't care. So, okay, and return it, and this is a type of article. Fine. So I run this now. What I'll get is this. Right? So now I've actually extended my application. Right? So the guys come along and said, now we want to add social commenting to our application. Fine. Easy. We've taken the original document and we've automatically, just as people inserted comments, we're pushing them onto this. Now if it's a document. It does underscore ID is basically the primary key of the root document here. Yeah, these don't have to have these. Yeah. Because they don't have, basically if you're going to drop this, you drop the article, which it will drop the comments. So what I can do here is, obviously I've introduced comments here and I'm pushing this in. If I call push again, what it would do is just add to the array. Right? So now if I commented, I could do it if you wanted to. Yeah, let's do it. So if I commented on here, now I've moved to the wrong, I haven't. Let's say that, I don't know, Fred wants to comment, doesn't matter what the name is. Yep. I don't know what he's saying now. You can see I called push. It didn't remove Bob's comment. It pushed it onto it. So it's pushing it onto this comment. So I'm now extending this as I go. Now, obviously, I can do the reverse of this if I wanted to. So what's the reverse of push? The reverse of this is pop. So I could say, upsert, find me the documents, and pop off the first one. So this is going to actually now, if I run this, put that to the top of the screen so you can see it. You can see Bob, who was the first one's now being popped off. And I'll do it again just to clear my document off. You'll see why. Now I have a document with no comments because I run it twice. So it's just popping it off, right? So I can push and pop things onto arrays. Now I can also, if I wanted to, I could have actually done a query and said, find me all articles that Fred has commented on. So you can do queries where it says comments.author is Fred. You could do that. Okay, so you can push and pop things onto an array. It's kind of interesting. You can use positional things to do that sort of stuff. Yeah. So, okay, we've done comments. So now you want to say, well, as a user, how many comments are there? Huh. Okay, interesting. So what I want to do is introduce a comment count that's atomic. Right? I don't want to basically have to always get this out and have to count how many there are. As I insert stuff, I want to increase the counter. Kind of a logical thing I want to do. So I can do this. What number are we on now? 4, 5. So this time, as I'm going to push stuff, so the same query as before, update push, I can also do a .inc, right, which increments a counter. So I just called it a counter on comments count. Again, it doesn't exist, but so it'll start at 0, and I'm going to increment it by 1. This is atomic, so the next thing I do, next time I execute this, and I'll show you, this is going to increase. So let's take the first one in. Let's just insert this little guy. You can see at the bottom of the screen, so there you go. So now I have Bob comments count is 1. Right? This whole update operation is happening inside one transaction. So now, if I say Red is going to comment, I'm just going to say hello. I'm still saying increment comment counter by 1. I don't know what the value of comment counter is right now. Right? I just know that I'm going to increment the value by 1. Now you can see, because it's acting on the database level, this comment count gets incremented by 2, to the value 2. Increment the existing value by 1. So you can see now my documents are taking shape. And I could add, obviously, more arrays, and I can add documents to that documents. And there's a bunch of, I'm not going to go into it today, but there's a bunch of talks that we do and thought that goes into schema design, right? When do you embed stuff to when do you do linking and referencing, that sort of stuff, right? And there's a bunch of rules about things to consider about how you scale, what sort of queries you're going to do, that sort of stuff. Okay. Pardon? So if multiple threads try to do that update at the same time, increment that counter, then they would wait for each other. So it's atomic. The update is fully atomic. So it will, one thread will increment by 1, the next one will do 2 and 3 and 4. Rather than you having to find the document in your application in one thread, then set the value to 5, let's say, and then another thread come along and also set it to 5, and then you can get contention. Then if you do it this way, then the database will take care of that via locking. What do you mean?
So if you had, and I know you said transactions are limited to one document.
Yeah.
If you had something you need to do that spanned multiple documents and you wanted all of them.
So there's a bunch of ways in which you need to think about this. So some of that comes around schema design. So whether or not if I wanted everything to be in a transaction, the typical answer is embed it into your existing document. And an individual document can get up to 16 meg in size. Another technique that I've seen people do is to put a version flag here and then increment the version as I get things. That's a bit more of a more complicated way of doing it. Okay. So if you read any blog entries, you'll hear people say, MongoDB lost my data. What's going on here? Right? Yeah, people blog about this all the time. You're like, oh, MongoDB lost my data. No, it didn't. Are you ready? You're going to play a game. Ready? Right, what was the 10th digit? Close. Technically it was 8. Right. So the reason that I did that is when I actually do my insert, right, when I did Mongo operations dot insert or save or update, it's a write operation. The default behavior, and I say it's the default behavior of the driver, is do an asynchronous write. This is extremely fast. And people say, well, MongoDB does this by default because they want to do benchmarking. But actually, we don't actually publish any benchmarks, so that can't be right. So the reason that this is the default behavior is the guys who wrote MongoDB were basically the guys who wrote DoubleClick. DoubleClick is a big ad-serving platform, right? It tracks clicks. Click. If I miss a click, I don't care, right? I'm just going to read the clicks as they come in, and I'm going to do basically reporting on the amount of clicks I've got on a click stream. So I want to, in that use case, I want to capture data as fast as I possibly can. I don't really care about durability. So the default behavior of the driver is to say, oh, just connect to MongoDB and leave, right? Don't care if it's a bad query, just here we go. Here's a bit of data and go in. Don't wait for it to write to memory. Don't wait for anything. Just keep inserting. Don't do this, right? Unless you've got a use case that basically says, it is clicking, going through a stream, or you have got a proper use case that doesn't really care about my data, then I wouldn't use this default setting. You can control durability at very different levels. And the very different thing about MongoDB durability and a relational database is we give the developers the control. You're now in control. You know your data better than I know your data, right? You know your use case. So if you want to make MongoDB work like a relational database, you can say write and wait for the data to be applied to memory and written to the journal on the disk and then returned to you, right? Clearly, if you're going to run a single node of MongoDB, this guarantees that you don't lose any data, right? So when I say insert, I give it a flag and say, make sure, basically journal safe. Okay, replication, right? So replication, here we go, right? Now I want multiple nodes in place here. A high availability, right? Yes, I can have a single node, and yes, I can write to a journal, right? To ensure I don't lose my data. But I want to do replication. I want to ensure that no matter what happens, the system keeps running. So data protection across availability zones, automatic failover. This is what I want to happen, right? These are my desired things. Automatic recovery across multiple nodes. So we have a replica set. So the way in which we do high availability is we have multiple nodes in play, right? Here's your Spring application, your Java app. It writes to a nominated primary, right, inside the set. So this is a single primary. And then this primary, the data gets replicated to the secondaries. Kind of makes sense, right? When you write data, you always write to the primary. And when you read data, the default behavior is to read from the primary. This is actually a good default setting. And the reason this is a good default setting is the fact that if I write something and then I go to read it, I basically want what I've just written, right? I want a consistent way of reading my data. For example, if I put something into my basket, a lot of people build e-commerce sites with MongoDB. If I put something into my basket and then I go and read my basket, well, I want the items I put in my basket in my basket. That's kind of a logical thing I'd want, right? So the default behavior is to always read from the primary. I'm going to talk about reading from the secondaries in a minute. But bad things happen again, right? This machine breaks, disks fail, I don't know. Somebody drives into the data center, right? The funny thing is, I was talking about a use case just about driving into the data center recently, and then obviously in Europe, the Amazon availability zone got struck by lightning, and one of the big telcos caught fire, which is, this sort of stuff happens, right? You could have these across different data centers. You could have them, obviously, in the same data center across racks. Obviously, put them across machines, right? Obviously, put them on the same box. If it fails, then what's going to happen here? Well, the set re-elects a new primary automatically. So it looks at who's got the most up-to-date data, and basically there's rules about, can I see the majority of nodes to avoid a split brain? And it elects a new primary. The application reestablishes all the connections automatically onto this new primary for you. So it calls this new primary, and then you keep going. Then I fix it. I don't know, I fix the disk or whatever I do to it. This goes into recovery mode, and then it automatically talks to the primary and gets the data that it missed, and then continues and acts as a secondary. And there's some more advanced features that you can say is you can make this guy a primary again with some configuration. Again, fully automatic. But this is the idea that I want to say my data is now protected and replicated across multiple nodes. So what's this got to do with losing my data? Well, a relational database works like this. A relational database, it writes the journal and it comes back again. Now, I told you, not that long ago that the default setting is fire and forget. Here it is, right? Your durability is going to be not very strong at this point, but it's going to be extremely fast. You could say W equals 1, which means ensure it's in memory on one node. So now I'm actually at least knowing that it's in memory. Depending on what your data is, that may be what you want to do. You can actually tune these on individual operations. You could tune it on, obviously, if you wanted to do it on the entire database connection, you could do that as well. But you can decide which operations need these particular requirements. So this is write in memory. This is actually write in memory and the journal. And then this is write to the majority of nodes. Or you could say n nodes, which could be 3 nodes, or it could be 2 nodes, it could be how many nodes you want to wait for that replication to occur. So if I did this, my application is going to wait until the data is not only in memory on one node, it's also on multiple nodes. It's on maybe another secondary, right? So now I'm actually ensuring that my data is, even if I lost the node, it's actually, I know it's been replicated to the other node because I waited for it. I'm not waiting asynchronously for this to happen. Yeah.
So how does all that, in terms of execution time, compare with something like Oracle RAC that does the same thing but doesn't give you a choice?
This is extremely different. Well, the execution time is massively different because they're completely different products and the way in which it works. We're structuring our data because the write of the individual write contains everything you need for this operation. So it's not going across multiple tables. Everything's embedded inside a single document. This is why it becomes, again, about schema design, ensuring that all that write is inside this given operation. Now, if you wanted to be really paranoid about this, obviously you could say W equals my tag, which could be all data centers, right? So now I'm going to wait in my application for this data not only to be in memory in nodes in my given data center, but also has reached to other data centers, right? This is still all of this is still going to happen behind the scenes even if you didn't do this, so it happens asynchronously. All I'm saying here is application wait, right, for the ACK this has happened. So if you do this, obviously you're not going to lose any data across data centers. There's no possible way that's going to happen. Now, obviously the higher up, this is why it's tunable. This is why we believe it's tunable, is you're basically tuning whether or not I want to have performance, right, to ensuring durability. And it's a trade-off that you have depending on what you are. Now, if, for example, this is a comment on a news article or website, I may do this. If I lose a comment, I know it's in memory. It's a comment. Who cares, right? Here, I say whether or not, maybe it's a payment, right? This could be, creating a user or taking a credit card information, whatever it is. Here, I'm ensuring it's across multiple nodes. So even if a node fails, I can't lose that data. Now, if it was, for example, a user, I use the expression, you don't want users... Oh, sorry.
Do I define these settings per individual update, or is that...
You can.
Okay.
You can do that in an individual update. You can do it at a collection level or at the database level if you wanted to change the default settings. So some people set, for example, W equals 1 at a very high level at their connection pool, and then so they never do this by accident, or then at individual queries you can change it. I use the expression, you don't want users to fix your apps. I don't use it to fix my app? What's he going on about now? This is because, imagine that I did this for creating users, right? So I'm using your app, I created my user, and you lost my user because you were doing this. Well, I fixed your app, I fixed all your load problems, I fixed everything. I go to another site, right? That fixes my problem, right? My load issues simply go away, I don't use your app anymore. So you don't want users to fix your apps. So obviously for user creation, you may do something like this, right? W equals majority and ensure it's on multiple nodes. How do you actually do this? Sounds more complicated than it actually is. So I can't even remember what number I'm on. 6, I think. Thank you. So here I'm going to do it at a reasonably high level, and I can say, here's it's called a write concern resolver in Spring Data. So here I'm going to say, right, if you get an action that comes in for this collection, if collection name is equal articles, return the write concern journal safe, else do normal, right? So I can actually set this at a whole collection level, I could set it at an individual operation level, I could set it at a connection pool level. So now, when I run my application in a second, what it's going to do is it's going to wait until the data is on disk in the journal for me. So that's the little class I define in Spring Data. I wire it together with, we're on 6, we're down here. So if you look at my configuration, I simply give it a property called write concern resolver, and it was referring to my class. Sure. So now, when I do here, my code, no, that's 4, that's not the right one. 6, this one. Now I'm going to insert data. My data looks exactly as it did before. Right, there's no additional properties I put here. And some of the, in the driver itself, if you were to use the MongoDB driver natively, you can actually put a comma separated here to make it easier for you, but Spring Data doesn't support that right now. So if I run this, obviously it's going to hopefully work. And I should now have 2 documents, right? So here's the second one, right? So from a data perspective, I don't see much change, but I've waited. My application is now going to wait until the data has actually been written to the journal. Yeah?
Can you enable the log to convert the object to like a real data? Like in Spring, we have the show SQL true, right? To show how the data is converting to the...
What queries are being executed?
Yeah.
I'd have to check in Spring Data if you can turn that on. I don't know off the top of my head. Yeah. Well, what I typically do, I don't do that. I would do things like, I don't want to click on that button. What you can do is, I don't want to connect to some remote machine. What you can do is turn profiling on here, and it tells you all the queries that are coming through. It actually shows you can turn profiling on for different levels. You can turn profiling on to show me queries that are being executed in less than 100 milliseconds. So by default, we claim that a slow operation is something that's taking longer than 100 milliseconds. But you can also turn on, show me all of them.
So the profiling is done
You can do profiling on Mongo side, yeah.
And there's no way to send that, right now, to send that information back to the app and consume that profiling?
There might be additional logging that you can turn on in Spring Data, but I've never had to use it, so you have to ask Oliver. Yeah.
Do you have any examples for showing how to handle the exception? I want to see just simple exception if you give some duplicate or something. I want to see
how it's going to react to that?
Yeah.
Okay. I don't have one, but it's basically if you put a duplicate here, I'm not setting the object ID. If I was to get an exception, then obviously this is going to throw out an exception and I can decide what to do with it. If something happens in the application perspective, I can't write or something like that, then I'll get an exception. It's up to you to deal with it.
Just like is it a very shallow exception tree or is it detailed? Like, are you going to get?
You're going to get very detailed exception.
Like in Spring.
Yes.
Stuff you get duplicate keys.
Yes. You would get duplicate key, typical reason. Yeah, you might get a duplicate key if you're replacing the underscore ID, the underscore ID yourself, and you're defining it as, I don't know, being user ID or whatever, you will get duplicate key exceptions, that sort of stuff.
None of this catching exception and checking the message, right, or code. It's specific.
You can do things like you can say get code if you wanted to, so you can do that sort of thing, but you don't have to. Okay.
In the case of when we have the large object, does it possible to retrieve not completely object but part of that? For example, if we have some object which contains some
Yeah.
binary data, it will be not reasonable to pick up complete object from the database.
What you can say is, I only want these fields.
Oh, it's possible.
Yeah, you can do that. Sure.
And we can add binary data inside of objects, right?
Yes, you can. You can add binary data inside objects. An individual document can get up to 16 meg in size. Now you think, hold on, I want to store I don't know, a PDF, right? A big image, right? That could get above 16 meg quite easily. The driver supports something called GridFS. So it's just a wrapper on the driver that basically says save file, right? Or find file. And what that does is it breaks the binary data down for you into separate little documents. And then you're acting on GridFS like find file, and it's breaking that up into little tiny MongoDB documents, and then kind of back and forth.
And MongoDB will manage those files.
Correct. MongoDB does that. And people like SAP use that all the time. Yeah. Okay. That's GridFS, yeah. GridFS, part of the driver. There's a driver for all different languages as part of the Java driver, also the C# driver, the Python driver, the Perl driver. There's all sorts of drivers. Okay. So that's write concerns. So there's also, obviously, eventually consistency that I could talk about, right? People talk about, well, what about eventual consistency? So MongoDB, by default, always reads from the primary. This gives you a consistent read, right? You can, if you wanted to, obviously read from a secondary, right? So let's actually figure this out. Let's understand what the differences are. So let's insert some data onto the primary, right? So insert, right? V1 of my data is going to be on here. That either asynchronously or synchronously waits for the data to get replicated, depending on what write concern you're going to use. So if I said, fire and forget, or I said in memory on one node, this replication is going to happen asynchronously, right? Okay. So the data now is V1 lives on the secondary. I can read. If this thread was to go and read off this primary, then clearly it's going to read V1, right? Because it's actually on the server, right? Fine. It reads V1. If I now go to update, so I got version 2 of my document, that can get replicated, fine. I go and read it, I get V2. Nice and simple, right? This is how it works by default. I read off the primary. Now, let's say that I have another thread or application over here that says, actually, I'm willing to read off the secondaries. So he's going to read off the secondary. Now, when he reads, in this time slice, v1 does not exist on the secondary, right? Because it may not have got replicated yet. Sure. So he's going to get nothing, right? v1's not there, sorry. But obviously, in this thread, he's reading v1, right? This becomes this replication. Here I'm reading eventually consistently because the primary is replicating that replication may not have occurred yet. And again, if I go to read v2, I might get v1 at this point. Right? This point here, v2 has not been replicated, so he's going to read v1. But obviously at this point, he's reading v2. Yeah? The data is eventually consistent because it's eventually getting to these secondaries. Now obviously when he gets down to here, v2 is on the secondary, so he's going to get v2. So it's eventually going to get there. So if you decide, and you can decide to do this, right, that you can read off the secondaries, but you are changing the semantics of your read. You're saying that I'm now willing to basically take an eventually consistent read. So what does this mean? I am giving you the use case earlier on about inserting stuff into baskets. So I insert my product into my basket that I want to buy. If I was reading off the primary, my product would be in my basket. If I read off the secondary, it's not going to be in my basket. Right? That's a very bad use case for eventually consistent. Right? Because I get frustrated when I go to my basket and my products aren't there. So now I insert more. That's not helping. It's actually causing more problems because now eventually I'm going to end up with two products in my basket. Right? However, it's a good use case if somebody said to me, Chris, what I want to do is I want to figure out roughly how many customers have got products just hanging around in baskets that they haven't bought yet. The guy doesn't really care, right? If somebody just inserted one a second ago, he wants an eventual, he wants a report, right, of the current, of the rough state of time. So you could do that sort of query off a secondary. Yeah, we'll come back to that guy in a minute. So, okay, 6, I'm on 7, aren't I? 7. Here you go. Yeah.
So the advantage of doing that then would be what, so that you just don't overload the primary server?
You could, some people do it in the idea to scale reads, because now I'm reading off other nodes, right? But obviously you're doing that, you're changing the semantics of your read. And I'm going to talk about how you can scale and keep that consistency if you wanted to do that. So all you simply do here is you say get collections, set read preferences of secondary. Now when I do operations, read operations, find one, it's going to basically read off my secondaries. At an operational level, yes.
Well, yeah, you can set it within the Mongo ops itself as default.
Yes, you could. You could set it in Mongo ops. You could set it in Mongo, which is the connection pool if you wanted to go quite high if you wanted to do that. And obviously you could set it right down here at individual query level if you wanted to do that as well. I believe they're looking at doing that. Spring Data is fairly new, so they're still got to advance on that. Okay. Right, so if I run this, I haven't got any secondary, so that's fine. Actually, I'll make a secondary. So it must sound fairly complicated, I'm talking about replication and multiple nodes now. Life suddenly got really complicated, right? So I'm going to do something pretty funky. I'm actually going to create multiple nodes here. So I'm going to start this node up, REPL.
What happens if you try and read off the node but you haven't created the other nodes? Just error?
That would actually work because it would just prefer back to the secondary. But so I'm going to create let's just call it Spring. Doesn't matter. Right. So I'm going to give my set a name. Obviously, I'm going to run multiple things on my box, so I'm going to, I obviously don't have multiple machines here, 27017, so I'm going to give it multiple ports. I'm going to run three different Mongo instances now running on my box. So here we go. He starts up. I'm just going to copy that for a second. So I've got one node started up in a set called Spring. Tab on this, make another shell. Machine a second. Oh, what's wrong with you? There you go. And let's just make another node, obviously running on a different port this time, 8, and what? Oh, it's slash, that's why. Just taking the dot out. There you go. Okay, so now I've got two nodes running. I'll just move that there so you can see I've got one node here, and let's make 3 nodes. So let's just do 9. Give it the same name again. 3. If you're going to copy something, copy the whole string. There you go. Right, so now I've got 3 nodes running. And I can go to my shell here, connect to one of the nodes. There you go. rs replica set.initiate. They're not pinging to each other. There's no multicast here. So I'll just initiate the set. So it's basically going to connect to the first node, the default node of 27017, and tell it to add itself to a member of replica set. So now it's becoming a member of the set. So I do rs.status. You can see I've got one set called Spring with one member called member 0 of a status of primary. And all I can do now, all I have to do now, is to rs.add, give it a string, give it the other node, so that's 8 and 9. And then I can do rs.status. Okay, so what's happening here is I have a primary, and I've just basically added the 2 nodes to the set. Yeah, so now I've got 3 nodes. I've got a primary, and 2 of them are basically now initializing into the set. Come on. So what it's doing is it's cloning my data. So initial clone. So it's pulling the data down, because I was originally only writing the news articles into the first member of the set, because that's what I was doing all my examples. So it's replicating that data for me. So now I have a primary and a secondary and a secondary. And that is a replica set up in less than, I don't know, 2 minutes. So what I can do now is obviously, let's do something a bit more interesting. I can connect to port, just to show you it's running, 2701. Let's just take 8 for the sake of the example. You can see now that I'm connected to a secondary. So let's kill this guy. Goodbye. Right? Chaos is now going to occur. And I can ask it what the status is. It says this guy is pretty dead. He's unreachable, sick. Now what happened was this guy got elected immediately as primary. So it basically called an election, a bit like the government. And it's going to call an election and decide this guy should now be the primary. And now you can see now I'm on the primary. And I could obviously say, if this all works for me, show DBs for a minute. I've got news, right? Because it got replicated down to me. And obviously I could do things like use news to show you the data is there. Show collections. Yeah, I got articles, db.article, find. Oop. There you go. Right, my data is there. Yeah. So the way the replication, the question was, is there a way of keeping track of what's getting replicated and listening for what's happening? So the way that the replication works is that they're connected to the primary, and they're listening to what's known as an op log, the operational log, which is a collection in its own right. So every time you do an insert, it's writing it to the op log, which the secondaries are reading to replicate off. a lot of people are actually written applications. It's very, very simple to do. It's just a collection to read the op log. People do this for things like integrating into Solr or integrating into other kind of tools that you just want to listen to events for. So you can listen to the op log for that. A lot of people are actually running on EC2. A lot of people are running on VMware, virtual machines. A lot of people are running on physical kit. The thing that really defines the performance of MongoDB is how much memory have I got in the box. Because the way that it works is everything is memory mapped and then flushed to disk. Then you decide whether or not you want to wait in your application for that flushing to occur. And also, obviously, it's going to be writing to disk. Right? So the speed of your disk, the IOPS of your disk are the things in which drive MongoDB performance. So yes, people run it on VMs, but obviously don't do things like memory ballooning, right? Where you basically try to fake how much memory there is in the physical box and then scatter it across multiple virtual machines, because that's going to affect MongoDB performance. But yes, a lot of people do run MongoDB in virtualization. Okay. So now, did I bring him back? I could bring him back, obviously. So if I bring him back on here, rs.status, he initially stinks. Oh, he's probably finished thinking by this point. He's nominated himself as secondary. Right, he comes into secondary, so now the system works. So I could, if I wanted to, obviously kill this guy. Now he's going to say he's dead. Yeah, no. And I could say, look at 9. And 9 is now a secondary, and I have a primary up here. Right? So it's basically electing them around based upon who's got the most up-to-date data at a given point of time, and who's got a majority. There's actually quite an interesting talk that I do about how this election actually occurs, but I don't think I've got time to go into that today. So now I've got multiple nodes in play, and let's just kill them all for a second. So does anybody think of what I've said so far, right? Is I have multiple nodes I could use. I could use a single node just with journaling if I wanted to. I could use replica sets for high availability, and I have a primary, right? I have people running MongoDB with large, and I mean hundreds of thousands of writes a second. How are you going to do that volume of writes through a single primary, right? That's not going to be particularly great. So, how can I fix this problem? So I can start off, obviously, cutting my lawn like this guy, right? I could start very small, a little scissors, and off I go. I feel quite sorry for this guy. I feel sorry for him, basically, because I'm looking at the size of his house and thinking, well, by the time he gets to the other side of his house, this is going to be long again. But, hey. But let's say this guy now buys a farm, right? He buys his big acres, right? He's got acres, right? I hope he doesn't do this. I hope he does this, right? I want to be able to get to here very, very easily. How do I do that? So MongoDB supports sharding. So it's range-based partitioning based upon a shard key of your choice. Right? So you're going to tell MongoDB how to partition, what key to partition your data on. Right? You shouldn't care how many servers there are from the application perspective. You just care whether and what key am I going to use to partition my data on. So as I insert, oh, that's crazy. So as I insert data, so db.users is a user collection. This is a command line way of doing it. db_users.save. Imagine I've got a document of just got people in, and I'm saving ages. So as I'm inserting data into MongoDB, what it's doing is, if I'm running a sharded environment, it's going to basically look at the data that's coming in and break it into what's called chunks. Right, so a chunk of data. So this is the people who are less than 40 and greater than 41 are in this chunk. Right, a chunk of data is by default 64 megs worth of data. You can change it up and down if you need to. But this is a chunk. Multiple documents live in this chunk. Now obviously as I insert more data, what's going to happen is I'm going to get more chunks. Kind of makes sense, right? So it's going to split the data. So as it comes in, and maybe I get a lot of people now who are above 51 coming into my database, and I'm basically going to break this chunk up into 2 smaller chunks, and then eventually break this chunk up into smaller chunks again. Right, so I'm going to build a little tree of data. So, sharding. A shard in production is typically a replica set. Right, so the replica set, the high availability that I talked about before, you can run it without sharding, with just 3 nodes or how many nodes you want to run. Or the key thing about it was it gives the individual shard, this shard, high availability. So there's 3 nodes in my previous example backing this shard. So this data is now replicated across multiple machines. I have 1 primary and multiple secondaries. But I wanted to scale. The whole point was I wanted to scale. So what I can do is I can add shards. db.run command, add shard. Now imagine I've got 3 boxes here and 3 boxes here. Now the data is getting distributed, right? Rebalanced across all of these. So you can see that now shard 1 has the users that are less than 40, and you can see shard 2 has these 2 chunks. Now the same document does not live in multiple shards, but a shard has multiple servers for high availability. So now, as I'm inserting data, the data is going to get partitioned between these, right? It's going to get split. So how does this work? This is probably the most advanced topic and the biggest thing you can get to in MongoDB. I have people with large volumes of shards, right? So you could actually, keep scaling these horizontally. You could add them in dynamically, right? So a lot of people start small, right? Maybe with a couple of servers, and then as they grow, they can add more shards. Now, the nice thing about that is a lot of people say, well, I'm building this in V1 of my application. I really don't. I would love it to be as big as Facebook. I would love it. But in reality, I don't know, right? So rather than going and buying loads and loads of kit, just in case I get as big as Facebook overnight, I can start small and add shards. Kind of decent idea. Now, I did say your application shouldn't care how many shards there are, right? Because if I'm going to add shards dynamically, the last thing I want to do is have to update my Spring app. I don't want to do that. Sounds like a bad idea, right? So what happens is the application talks to something called a MongoS. It's a little tiny process that typically will live on the same machine as your Java application in this case. Right? So it's living there. It's a little software switch. What it's doing is it's taking responsibility of routing your queries and your inserts in the right place. So MongoS knows how many shards you have, and it basically says people in this previous example here, I shouldn't have put graphics into that, and it's going to flick again, I know it is. Yep, thanks. Don't double click. So it knows that people aged between 41 and 50 live on shard 2. The MongoS knows this. So what it's going to do is it's going to route that query over here. And it's going to insert the data in that range, in that chunk range to over here. Now obviously, as let's say that I do get a lot of people in a particular range, the data can get rebalanced. So MongoDB supports auto-balancing. It detects if one of the shards has too much data, and it moves the data to another shard for you. It actually moves chunks of data. Now, how does the MongoS know where the data is? And there's multiple of these. I don't want a single point of failure, obviously. As I spoke about at the very start of my talk, you can scale your app servers horizontally. Right? So now I may have not one app server, I may have 20. Right? So what I do is I talk to my local MongoS, or my little box, and it knows where the data is. It knows where the data is because it's asking what's known as config servers. Right? Typically in production, in a sharded environment, there's 3 config servers. You can run 1, but what's going to happen is the data is going to get partitioned. And they know whether or not data has been moved. They ask the config servers. Does that make sense? Okay. So we rebalance. So let's imagine for some reason, and there's a bunch of reasons why you could get into this state. You've got a bad shard key, or let's say that, you've got a bad shard key that's, let's say, based on time, right? So you pick your data that you're going to, the key you're going to partition your data on. Now, obviously, if I pick time increments in value. So what I'm going to possibly end up, if I had a bad shard key, is with an imbalance, right? All the data going to one particular shard. So Mongo S, one of them calls itself and it says, I want to issue a balance, a rebalance. So it acts as a coordinator, and it talks to this guy, and he says, hey, you've got too much data, right? These guys have got lots. These guys have got room. Why don't you move some data to this guy? So it issues that instruction, and the data moves, right? So this data moves over here. During this time, this is still going to serve until this acknowledges that it's got all the data safely onto this node, and then updates the config servers, and they all keep going. Right? So this is auto balancing in MongoDB. So you end up like that. Okay. I was trying to figure out. I got enough time. Okay. So again, this is, this sounds as if now I've gone from a single node to multiple nodes to sharding, right? Whoa, this is getting a little complicated. So let's not do that. Let's go here. It's up. I'm going to actually do something really, really crazy and actually set this up live in front of you. So I'm going to, rather than, I've got limited resources, so I'm going to just create two shards. One's going to be on 2701, 2727, just give it a port number. So there's one node, it's got no data in, right? This is just one MongoDB process, right? It's a database. That's all it is. Let's actually copy it with the dot this time. Would be good. Let's work another tab. Okay. And let's make shard 2. Now these obviously could be members of replica set, but I haven't got time to do that. So here we go. I've got 2 MongoDB processes running. I need a config server to know where the data is in case it gets rebalanced somewhere. So the shards may have to rebalance the data as I insert the data into it. So let's just change this to get rid of this. I should get rid of all of this. Get rid of all of this. Okay, so there's a config server, and I'm going to hack that for a minute. Need that. And I'm going to now talk to a Mongo S. What am I doing? Mongo S. Minus. I think I stuffed that up. So I did. Config DB. Oh, SVR. So it knows there's a config server. Config DB equals, and tell it where my config server is. 27019. With a bit of luck, it starts up. So now I've got a Mongo S, the switch. I've got nothing running on that port. I've got a config server, and I've got 2 little databases. So what I've got, going back to this diagram for a second, I've got a Mongo S. In my example, I've got 1 config server, and I've got 2 shards. Well, I haven't got 4 shards. Yeah, go.
So originally you had like 2 backup Mongos for
yeah.
the primary. So you can have a shard with dedicated backups for each shard?
Correct. That's exactly how it works. Yeah. Obviously, I would do that, but I've got limited resources on my Mac. So, okay. So here's my Mongo S. It's running. Now, if I connect to Mongo, Mongo, it tells me you actually are connected to a Mongo S. You connect to the switch. I expected that. I could say sh.status. And it's going to say, okay, you've got, I basically started from scratch, so you've got no databases, you've got no shards, because they don't multicast to each other. They don't know anything about each other to start with. People typically don't like people multicasting around. just going to use a host name. Okay, that's just me shortcutting for a second. Okay, so what I want to do is add a shard, right? sh.add_shard. So it's a host and port. And a little bit of luck, it says OK. Let's add the other one. Okay, sh.status. Yep. Okay, here we go. So I've got two shards, 27017, 27018. So the system now is set up to, basically, it knows that exist. Now, when I say I shard, I actually shard individual collections. I may decide that I want to shard my articles, what I'm going to do right now, but I may not want to shard country codes because, well, it's too small, right? It doesn't make any sense. So in that case, I would say the country code collection is not sharded, but it lives on shard 1, which has a replica set in it, which has a primary, multiple secondary. So even because it's only on one shard, if I lose the primary on the shard, I'd never lose my data because the shard has high availability built into it. Okay. So now I want to say -sh.enable sharding on the database called news. That's correct. Okay. So now I can say sh.status. Oh yeah, I forgot tests. You can see now I have news and partitioned is true. So basically said that there are some collections in here that could be partitioned. It's homed on this. So let's go back and have a look at my data for a second before I do actually show you this. So if I show you that number, where are we? 8. Thank you. Where's 8 gone? 8 is right at the top. There you go, obviously. If you look at my article, so here's article. I have a bunch of properties that I had before. I'm going to shard on author ID. Right? I just made a UUID. I just wanted a key of some description. It doesn't really matter at this point what it is. Okay. So sh.shard collection. And I wanted to shard the collection in news. Article, articles. And well, what do I want to shard on? Right? I know I'm going to shard on this collection. But what key? Well, was it author ID, wasn't it? I almost stuffed that up. Author ID. Is it little ID? Yeah, it looks like that. Okay. 1. 1 for ascending and descending. It's an index, right? So I haven't gone and talked about indexes today, but MongoDB supports indexing that are B-trees. Okay. Okay, it says that's fine. sh.status. You can see now, put it at the top here, you can see now I have news article, and this is partitioned, and I've currently got one chunk. Ooh, I should move that across so that you can see it. There you go. Let's put that over there. I've got one chunk. It's on shard 1. It's on shard 00, and it's just one chunk. Right? So basically all my data from minimum and maximum range. It doesn't know. I haven't told it anything else. Okay, so where's that gone? Let's just go a little crazy here. Actually, let's just do 1 to make sure that it works. 1. Right. I haven't actually tried this yet, so I'm doing a bit gung-ho here. Okay, so I've inserted some data. Now, I would expect it still to have one chunk, right? Because a chunk is 64 meg of data. I've only inserted one little tiny record, so that's not going to give you more chunks. But if I say use news and say show collections, oops, it's got the bottom of the screen again. It's here, and I say db.articles.find. I've got 1. Okay, I can even say count if I want to, just to ensure you I've only got 1. Yeah, I got 1. Fine. So let's just go absolutely crazy and totally kill my machine. Maybe that's a bit too high. Okay. Okay, so now it's just going to loop around creating more and more articles for me, right? Okay. So now, if we do sh.status, I'm going to have to wait a little while. Yeah.
Does it batch in
you can do batch insert. It's actually pooling the connections underneath. So the default connection pool is 10, but you obviously would increase that normally. You can do batch inserts if you want to do. I'm not doing that in my example. So let me just show you this. So what's happening here is it's looking at the data as it's coming in. Now I would typically do it slightly, if I was doing this in production, I'd probably give it some hints about what the keys are going to be. But basically it's looking at my data. And it's saying, actually, you're getting a lot of data on this shard here. And what's happening is it's deciding to split. So it's looking at my keys and saying you've got random keys. You know, I can split these in certain ways. So it's making rules and saying, actually, I'm going to split this bin data, which is just my UUID, split it this range, between this range and this range, and put it on shard 0. Let's find it up here. So yeah, we've got the other one up here. Minimum key to this range is going to be on shard 1. And then it's basically rebalancing the data as it comes in. This machine's struggling now. There you go. It's slowly rebalancing, right? 4 and 6. Okay. Yeah. Does it block the update? No. But obviously, the rebalancing doesn't come for free, right? It has to do something. So it has to move data. So that it does obviously take IOPS to do that. So obviously, what you can do if you wanted to is give it rules about pre-split rules about I want this range to be on this range first, and then it doesn't need to rebalance. Or you can say is I want the balancer to run in this window, so in the middle of the night when it's quiet. Or I can turn the balancer on and off dynamically. So if I know I'm under heavy load, I can just dynamically turn it off to do that sort of thing. If the balancer is off, only simply it's going to mean is that it won't rebalance. So you might get a hot server because all the data is going there, but you can still insert and do other stuff. They're not out of the box, but some people have, I know what some people have done is linked it to their monitoring tool. So if I'm seeing lots of IOPS, turn the balancer off. You could do that. You could do. Yeah, they can do. People have done that sort of thing. Something that we probably, may look at later. Okay. So that was, in a 90-minute session, we've built an app, a very basic app. I'll give you that. But we've, done replication of a database, and we've horizontally scaled the database, right, from pretty much nothing, right? Sharding. Now, there's loads of other features in which I could have talked about. There is more concurrency we improved. We just launched 2.2 as our next version. There's tag-aware sharding, so you could say, I want particular data to live in the US and not in China, for example. I don't know why you want to do that, but you could. You could say aggregation framework, which is a really powerful framework to allow you to do grouping. So you could say, find me all the documents in this collection, which is one operation, match me all documents in this collection, and project me out a document that has a different shape, so maybe has different fields or whatever fields you want to filter on, and then group them by, let's say, location or users or whatever you want to locate on. So you can do aggregations and sums and averages and all sorts of things. There's also TTL, which is time to live collection. So if you've got documents that only have a certain life, let's say I'm inserting things and it should be a day or it should be like a minute or whatever, then it will automatically remove that for you. If you want to find out more information, we do one thing you could do, as you go to we're doing a training course completely free. It's online, it's structured, and you can just sign up and do the classes. So I'm happy to take questions at this point. Taking questions are gone. But any questions? Yeah. Pardon? We don't support multiple masters. So the way in which you would scale in MongoDB is you'd have sharding, as I described. Typically, you would use a replica set for high availability. That's the main reason for it. Some people are reading off the secondary if they know that they've got a use case that is eventually consistent. You can read off the secondaries. But my only word of caution on that is that some people think they do, but they don't. Right? So if you are sure that you have a use case that's eventually consistent, then sure, you can read off the secondaries. But typical use cases are there for high availability. And they could be across, obviously, racks or across data centers, depending on what you're going to do. Where's that coming from? Pardon? How do you do indexes? So you can have you can have indexes on any field that you want in the document. You can create secondary indexes, and you basically can say, create me an index on author in my example, and they're B trees. So when you go and do a find, it will look in the index, and rather than doing a full scan, it uses a B tree to quickly decide that. You could create it on author or timestamp, or when I had comments.author. So I could have indexes on embedded things inside properties. They're all B trees. You can do compound. You can also, they're all B trees, and we also support geospatial indexing. If you wanted to do find me all places near here, sort of stuff. Yeah, I'll take you first. I would say that MongoDB, you don't need to keep everything in memory, right? So maybe I confused matters when I said, MongoDB, yes, it does use large volumes of memory, right? As you insert data, it's going to basically store that data in memory and flush it out. Now, what you want to keep in memory is what I call the working set, right? Your active user base, right? You don't need to keep your entire database in memory because it may not make any sense, right? Let's, for example, I'll take you two extreme examples. One of them, I have a large telco that's doing voice over IP, and he has hundreds of nodes, and what he has is his database is in memory, right? He has hundreds of nodes, and the reason that his database is in memory is that it's keeping metadata about current active calls. So what they care about is obviously voice quality during the call, right? So they want to ensure that everything's in memory for speed. Other people who are, let's give you another use case, I'm just reading a log or reading an event stream. And what I want to do is I want to do queries and aggregates on what happened this week or what happened today, or I might have been reading this log for like a year or 2 years or whatever, right? That 2 years worth of data, it's just on disk, right? Because most people are querying on what am I doing, what happened right now, right? So it's very much keeping the data that's in your active data set in memory. Yeah.
So Spring Data Wrapper, does it support all of the operations available on the console?
It supports almost all the operations, and what you can actually do. I'll show you very, very quickly because it literally is a 30-second thing. Let's say that I've got, where's my operation, ops. I can actually go to ops.get get collection by name A. I'm just going to put A for now. Is that right? Why does that not work? I understand. Oh, give me a break. Get collection names. That's right, I did wrong. All right, A. What's a class? Okay, article. Well, basically, I shouldn't have done this now. No, I wish I could quit. It's get collection. That's what I was looking for. Oliver's putting his hand up for me. You can also fall back down to the native driver if you wanted to. That's where I was going. So this is the native Java driver at this point. It's get collection. And you can see here, these are DB object collections. This is actually the underlying Java driver if you wanted to get to that level. And that has basically everything the shell has as well. So you can actually operate at different levels depending on what you're trying to achieve. You can do MapReduce in MongoDB. So what you typically do that for, yeah. So here you'd say execute map. Actually, Spring Data has a wrapper around MapReduce, so you can even happy with that. You can basically would execute a MapReduce job that would output to another collection, which you then read. Yeah. Yeah.
So for the replication, can I use a list of sync and async, for example, within the data center?
Sure.
I like them with sync for replication, but across data center, I like them with async.
Right, so you're controlling it at individual operational level, right? So you could actually say that I want, let's say I do an async operation to start with to save something. What's going to happen, you're going to write to the primary, and behind the scenes, asynchronously, it's going to replicate to across data centers. And then you may do another operation, I don't know, another save or whatever it is, that then says, I want to actually wait for the replication to occur, right? So it's still going to occur like it did before, but you're going to wait for it for an ACK. So you can actually control which operations you want to block for. I can take one more, otherwise I'm going to get kicked out. Where are you? Sorry, I can't see. Yes. You can. So MongoDB itself, in the database, in terms of the schema, won't validate the data, right? So obviously your applications has the domain model in it. So obviously you could put annotations around it to say, must not be null, must be time, must be whatever. But the database itself doesn't care. So the nice thing about this is that some people think that's rather scary, and other people say, well, actually that's really powerful, because now I can add fields dynamically and I can change the type of stuff. Well, you could use. That's just Spring, right? Yes. He's nodding at me. Yes. That's Oliver behind there who writes Spring Data, MongoDB. Yeah. For data migration, there's no actual framework that I'm aware of, but what I tell you techniques people do, what techniques people do is they basically have the ability to, you got two options. As much as I've got a large data set, I've got people with petabytes of data, right? Trying to run one big job that goes and updates everything in one batch job is going to take you a long time if you've got large volumes of data. But I'm working on a current working set, so as you load data, you may be introducing the new field as it comes in, right? So you now have a version flag, a version field in your document. You read it as version 1, but you save it as version 2 with the new shape of your document. So you can do that in real time. And then later on, let's say after a week, then you execute some sort of script that goes over and changes your data. So that's typically how people are doing it today. Okay, well, I think I'm out of time. So thank you very much. I'm going to be here all week.